So let's practice another null alternative hypothesis and rejection region. So last year the mean composite ACT score for high school students was 21. A random sample of 100 seniors is taken this year, and the sample average here, composite ACT score was 20.7. Is there reason to believe that the national average has changed from last year? Alpha equals 0.01 significance level. Assume the population standard deviation here is 1.8. So first they want us to state null and alternative. So we got H0 and HA. So remember, HA is what you're trying to show. They want to know if things have changed. So, and is there reason to believe that the national average, the mean, has changed? So mu not equal to 21 was last year. So that would be a change. And if that's not the case, then the mean is still 21. So equal, not equal, that's a two-tailed test. So we are going to have two rejection regions. And the cutoffs here, so alpha is 0.01, two-tailed test plus or minus 2.575. So 0.01 is the total area of these. So that means 0.005 on each side to make up 0.01 total. So this cutoff here is really z.005. And it's 2.575. And then this one is negative of z.005, negative 2.575. So that's the first two steps in a hypothesis test. Set up your null alternative and sketch your rejection region based on alpha. So this other information, we didn't need that yet. So let's also talk about what to do if your alpha is not something that's in the table. So here our alpha was 0.01, that's one of the common values. What if alpha was, say, 0.04? Still two-tailed test. What do we do? Well, we still got our two rejection regions. And so that means that the alpha is split equally between the tails, because remember, alpha is the area of the rejection region. So this right here is going to be 0.02, and then this over here will be 0.02. So this z value is going to be the z-score with 0.02 to the right. That's our z alpha. So we can get that by doing inverse norm. So just do inverse norm. And then the left area, if O2 is to the right, then 98% is to the left. So this will just be inverse norm of 0.98, mean 0, standard deviation 1. So let's figure that real quick. So we go to second variables, distribution menu. Number 3 is inverse norm. Left area 0.98. Everything else is the same. 2.05. Usually round these to 2 decimal places. Sometimes 3 if you want to. So, and then this one would be negative 2.05. Then if it was an upper tail test, excuse me, if it was an upper tail test, this would be z.04. If it was lower tail, it'd be negative z.04. So that's how you deal with something that's not in the table.